Hi, I'm Bob Vila. Welcome home again. Well, here we are in Roxbury, and we're working on our single-family house with special accessible features, but today we're putting in something that every house needs, a boiler, a furnace for the heating system. It's a Buderus unit, state-of-the-art cast iron boiler. We're also taking you to Wetzlar, Germany to visit the plant where these are manufactured. And when we come back here after that, we'll be installing a Honeywell thermostat. Stick around, it's great to have you home again.
Sears presents Bob Vila's Home Again.
Let's say hello to Steve Offit from the EPA and Chris Hoff from Buderus.
Hi. Hello, Bob.
Now, the Environmental Protection Agency is involved with this new program, right? You want to tell us a little bit about it?
It's the Energy Star program.
Right.
Energy Star is a label, a distinctive label that people use to recognize that it's an efficient product, more efficient than a standard efficiency, for instance.
And this applies to boilers as well as to kitchen appliances and the like?
Exactly. The Energy Star label is found on a vast array of products, from heating and cooling systems to kitchen appliances to home electronics. And what it does is it tells the consumer that if they buy a product with the label, they'll save money on their utility bills and they'll reduce air pollution. A lot of people don't realize the average house actually pollutes more than the average car.
No, can't be.
Actually about double. And the way that happens is most homes are heated by burning something like
oil or coal, yeah.
like natural gas, for instance. So that creates air pollution. And the other way is by using electricity. Refrigerators, lights, and so on all use electricity, and that's generated at a power plant,
right,
which generally burns coal or a petroleum product. And all that pollution adds up to a huge amount.
And it is hard to believe that a house would be a bigger polluter than a car, but that's the truth.
It is the truth. And if you look for the Energy Star label, then you can reduce that air pollution and save money at the same time.
So the Buderus company is participating, and of course they manufacture the boiler that we're installing here.
That's right, Bob. As an Energy Star partner, we have manufactured products that feature a variety of Energy Star products. And what you see here is a product that's 85% AFUE rated, which is the requirements of the Energy Star program for qualification.
What does that stand for?
That stands for Annual Fuel Utilization Efficiency.
Efficiency.
That's correct.
And 85% is pretty good.
That's pretty good, sure.
Yeah. What are some of the features of the Buderus boiler?
Sure. Some of the additional features for energy savings are the insulation. A conventional boiler will offer 3/4 to 1 inches of insulation.
Right.
What we have here is a full 3 inches of insulation. And what that does is it keeps the heat on the block, and it's allowed to go to your radiant systems.
So that it cuts down on the wasted energy while it's in a standby situation.
Conventional boilers, typically there's 15 to 20 times the standby loss that you can see. Whereas we keep the heat where we want it and we put it in the house where it's needed.
Yeah, and what's this pipe you guys were talking about a minute ago?
What I've got here is a stainless steel burner tube, and a conventional boiler will typically use a steel-coated or a steel tube, aluminized, that's punched or pierced. What happens is, over time, corrosion will occur. And with that, the increase in diameter of the holes will cause the CO emissions to increase. So with a stainless steel tube, we're able to have a substance that will not corrode and maintain the same emissions level, so it's environmentally safe throughout the life of the boiler.
The technology is impressive, and actually, not too long ago, we took a tour of the Buderus plant to learn how these are made in Germany. Wir sind nach Deutschland gekommen. We've come to Germany. As guests of the Buderus company, we're here in Wetzlar, a wonderful city that's over 1,200 years old. It was an imperial town back in the 1400s, which meant it answered only to the emperor, and it was a cultural center as well. But this is really where iron manufacture begins, well over 1,000 years ago in this part of Germany. It's also a place where slate is mined along the riverbanks, so that everywhere you go you see beautiful slate roofs and even sidewalls of houses done in slate. It's a famous place for other companies besides Buderus. Leica cameras are made here. But we're really concentrating on the Buderus company, a foundry since 1732 where they made cannonballs and anchors, but today they make some of the world's best furnaces and boilers. We'll join Herr Schulte, who is the head of research and development, and will give us a tour. Well, Herr Schulte, it's such a pleasure to visit the factory here, but I think before we start talking about the process of making cast iron elements, would you tell us a little bit about the history of the Buderus company?
The history is very interesting for Buderus company. Buderus was founded in 1731, and it started firstly as a private company by Mr. Buderus.
What were they making back then?
They're making tubes in the beginning, and some casting, some cast iron casting. They started the production for cast iron boiler sections. It was when this plant was founded here in 1861.
And now what we're looking at behind us, and it's pretty amazing, is the actual molten iron that's being poured into buckets, right?
Yeah.
How hot is that? What's the melting
the temperature here, the liquid iron temperature is about 2066 degrees Fahrenheit.
Wow. What's the first step that's happening here? What are they actually doing?
The first step, the melting step, that's the first one. They're beginning to melt the cast iron with the raw material.
Right.
And there's four very important parts for the raw material. That's pig iron.
Big iron.
Big iron and scrap, steel scrap and cast iron scrap. The fourth part is cast iron, which is circled around here. So that's recycling material.
This is an industry that has always recycled itself.
Yes, okay.
Right. And so the molten iron is transported in these buckets or hoppers.
Yeah, that is the first, when it's come out from the cupola furnace, then it comes to the big iron receiver here, where the liquid iron comes out. And then it's bring to the small receiver here, and then it goes from the small receiver to the automatic molding lines.
All right. And so I guess we'll just follow the man in the orange front end loader and get an idea of where it's going next, right?
Yeah.
Well, Herr Schulte, there's no doubt that there's something magical about watching molten metal, this hot orange liquid being poured into molds. Can you explain to us the process here?
Yes, I can do that. We are standing in front of the automatic molding line, and the process is starting with a sand, with a black sand. The black sand consists of coal, bentonite and water, and this sand will be pressed.
But the black is actually graphite, isn't it?
That is graphite,
yeah.
Yes. That's graphite, that's correct.
All right.
And then the core comes in, and we have the upper case, we say, and the lower case.
Right.
We bring them together, and then the mold is finished.
And what we're making is sections for a boiler, right?
Then we make sections for the boilers, and when the mold is finished, then we bring it here to the iron receiver, and we pour in the liquid iron.
Okay. And so each one of these that we're looking at behind us has a mold in it.
Yeah.
And what are the flames that we see coming out of the
Yeah,
top?
that is some gas which comes. That's all originally waste. So we see here the big exhausting system that we have installed here. And you see the big lines over there. And all this waste pollution is filtered inside because we have very strict regulations here in Germany that not air pollution will be the result of the foundry process.
All right. Great. Let's go see the next step.
After we have poured the cast iron sections, we cool them down to a temperature of about 480 degrees Fahrenheit.
So they cool down from 2600 to 480 degrees.
Right. Then we will bring it to the cleaning station where they are shaped and where the dark sand is coming out and the coarse sand is coming out.
Is that all recycled?
We are recycling the black sand, the carbon sand, nearly 100%.
Fabulous.
And you can see this is the clean, cooled down cast iron sections.
Right.
And this is the areas which will be milled and polished.
So this is cast iron, but it could actually be threaded, almost like steel.
That is specific cast iron for boiler sections.
So that's part of the secret patented technique. And
This
once
is
you put them
before-
through the mill,
And this is when it's milled and polished afterwards, and you see it, it's very blank and smooth.
I can't believe that's cast iron. That's amazing. You can get that sharpness with cast iron.
That's it, yeah. And after this, we have the pressure test, 100% by 58 psi. That's the first pressure test, and afterwards we have another pressure test, also 100%, when the block is completed. So we start here with the tested boiler block on the assembly line.
Okay, and then at this point the burner comes and meets.
And the next point is that the burner comes in here.
Now how do you test them?
The tested is twice. First standalone, and first is tested in the unit.
So you're actually putting gas in there and
We put the
firing it
gas
up?
in and look at the gas leakage and so on.
Yes. And then once they are installed in the actual boilers that are going out, they also get dressed in the insulation jackets, right?
Yeah, we put on the insulation, and the next step is then to bring on this boiler jackets here in this fabulous blue color.
Yes.
That's the Buderus color.
Now this is a trademark of Buderus,
That's
this
a
blue?
trademark of Buderus. Yeah.
So that makes it a distinctive product all around the world, right?
That's right.
Once you've got them assembled, they go
That's
on
a
the
front.
pallets, into the boxes, and out the door.
That's the last step here, out the door and up to the customer.
Well, we're very happy to get an idea of German technology at the end of the century.
Thank you very
Und
much.
Vielen Dank.
Dankeschön, Wiedersehen.
We'll be back in a moment to finish the installation of our Buderus boiler at our house in Roxbury, Mass. Okay, now we're still dealing with our Buderus boiler, and Peter Leiden, who's our plumbing and heating contractor, is putting the finishing touches on the installation. And we've been looking at all of this part of it, but you know, these are all the parts that you have to get at the supply house. And Peter, help us understand a little bit here. It's a hydronic system. We're going to be heating water in a boiler and distributing it through the house. What are all these pipes that you've connected?
First of all, this is the feed from the city. So this is to shut out the isolation valve, comes into a check valve. Not that the
So that's where the water will be coming into the boiler.
comes in here. This is a backflow preventer from get back into the city water.
Okay.
Anywhere else. This is automatic feed. This is a manual. If you want to fill it fast, leave it at set about 15, 20 pounds.
And that's something that you don't mess with much anyway, because once you've got the system filled, it's filled.
That's right.
You don't have to keep adding to it. Yeah.
That's
and
right.
then what's this here?
This is just my gas fit to it. So my shut off, my union to disconnect it later on. My isolation valve again, gas
Okay.
cock.
Yep.
The water.
And then what's all this back here?
This is a direct vent motor. To vent it, I can directly vent it right outside the house. I need no chimney.
Yeah, this is the kind of technology that doesn't need any kind of a chimney flue, but it will go out through the foundation, or will it go?
Right through the foundation.
Yeah, right. Okay. And then what were you just tightening up here?
This is an expansion tank. When I heat the water, it expands. This prevents it from the relief valve blowing off.
Exactly. So that takes the extra water,
The excess expansion.
Uh-huh. And this?
This is a circulating pump. It pumps the water into the system on the supply side. So when it calls heat from a zone valve, which opens up with the thermostat upstairs.
Now I see 3 returns here, so I assume we've got 3 different zones?
That's right. First, second, third.
First, second, and third floors, right. And, well, you still have a ways to go. Now, you know, one of the things that I think a lot of people might be concerned with is the fact that this is European technology in the States, and what about, you know, maintenance and stuff? Tell us a little bit about that.
European engineered and American assembled. What we have here is our ecomatic control. A typical boiler or conventional boiler control will operate between a high and low limit of 180 to 200 degrees.
Okay.
So what that causes is you to waste a lot of energy and money ultimately in keeping the boiler at a higher temperature.
Right.
With the ecomatic control, what we do is control the water temperature based on the weather changes outside. So typically what happens is you have a lower average temperature between 130 and 140 degrees. So you can see through fewer burner starts with respect to the outdoor temperature,
Right.
you get a significant amount of fuel savings with the unit.
Exactly.
The control itself works like an setback thermostat.
Ah, okay.
So it has a variety of custom programs, heating programs, for the comfort of the homeowner, and actually a vacation setback. So if you're leaving the house, you can press the vacation button, your system will be fine.
But it still works in coordination with the upstairs thermostats,
exactly,
right? Yeah.
exactly.
And what about down in here? Are these American controls?
What you have here is all Honeywell components. So you have Honeywell gas valve, Honeywell Aquastat.
Okay.
So they're easily serviced from any wholesale supplier.
Right. And the panel, of course,
Sure.
makes it
Let's fit this on.
makes it very neat and tidy. I like that European design.
Sure.
So we're ready to do a little soldering up here? And that's one technology that hasn't changed much over the decades, right?
No, it hasn't changed much.
A little flux, light a match, and you're off and running. Draws it in and it's done. Now this won't be ready for testing for another
Couple of days.
couple of days, right? Thanks, Peter. Thanks a lot, Chris.
Thank you, Bob.
Okay. There's a lot more coming up, so stick around. We'll be right back. Let's say hi to Brad Owens, our electrician.
How are you doing?
We're down to the finish work around here, Brad, right?
Yes, pretty much.
Installing a thermostat. And this is not just an ordinary thermostat, is it?
No, it's not. If you look at it, you'll see the enlarged numbers on there that are easy to read, and also by touch, you can also really feel them.
Exactly. It's raised numbers, big numbers, so that anybody with sight impairment can really see them easily.
Exactly.
It also clicks every second degree so that
Yeah,
you can hear it.
It clicks every 2 degrees.
It's the easy read from Honeywell,
Yeah.
right? Isn't that what they call it?
Exactly.
Yeah, the easy to see heating and cooling thermostat. Otherwise, it's a simple thermostat.
It's a simple connection. It's a 2-wire connection here, right to the 2 terminals that are already on here. I already have my anchors set in place.
Into the plasterboard.
Right. And I'm just going to level this up once I get it here and mount it.
So why do you have to level the mounting plate?
Well, you have mercury inside the inside your thermostat here.
Right.
And you want to make sure it's balanced. You don't want to get the burner to turn on when you don't want it to turn on.
Exactly, because the mercury is inside this glass vial, which is attached to the metal coil. And the metal coil expands when the heat rises, contracts when it gets colder, and it affects the mercury going back and forth, which essentially makes the contact to either turn it off or turn it on.
Correct.
Right.
Let me check and see if this is level.
There's just enough play there to make a minor adjustment. Yeah, you better put the level back on.
Yeah, it looks pretty good there.
All right.
Tighten it up.
Okay, and it's a simple 2-wire thermostat, which means there aren't any night setbacks or anything like that, right?
No, there's not. Just a simple 2-wire. Just going to put a little hook in these.
And so that 2-wire, you can hook it up on either side. It doesn't really matter.
No, it doesn't matter at all.
Okay, and then this is the part that just interfaces the contacts, right?
Correct.
It's not hardwired, just mounted in.
It's just mounted in. Everything these screws are going to line up, and these 2 here will make the contact.
Right.
Okay. So.
Okay, and then the last step is to...
Just put this little faceplate on here.
And so the numbers obviously correspond to the 50s, 60s, 70s, and 80s. And right now it would be set right at, what, 68?
68, correct.
But it's supposed to click when you turn it, right?
Yeah, you turn
You can feel them, yeah.
Right, yeah.
There you go. All right, thanks, Brad.
Okay.
We'll be right back with a preview of our next show. Stick around. Okay, that wraps things up. Come home again next time. We're going to be installing a white cedar picket fence around our corner lot here. Inside the house, Riley will be here to help us put some pine panel doors in place and install the Schlage hardware. So then, I'm Bob Vila. It's great to have you home again. For lots of information and resources for your home improvement project, check out my website at bobvila.com.